Significant figures are a way to measure the precision of a measurement. And the idea is that not all measurements are the same. So if I have a scale and I weigh a mass and I get a reading of 1.15, and then I take that same mass and weigh it on a different scale and I get a reading of 1.1524, we can say that this second measurement is more accurate. But what we need is a way of defining that to be able to show that this measurement is more accurate. And the idea is the greater number of significant figures in a number, the greater the certainty of the measurement. And what we're going to get into is the idea that the precision of different measurements is going to affect calculations. So say I measure volume and I measure weight and I calculate, say, a density from that. How many significant figures are going to be in my answer? And that's what we're going to talk about right now. So significant figures affect your answer, and there's going to be some rules that we're going to discuss in order to do that. And kind of the hard part here is depending on who's your teacher, different professors have a different level of want in terms of the number of sig figs on an exam. But to be safe, you should probably put the proper number of significant figures on every answer on every exam till you're done with general chemistry. So that's one of the ideas. You need to make sure of this, and it's one of these things whenever you do a calculation, you want to take a second and look back at your given numbers and try to determine how many significant figures your answer should have. And some professors are kind of nutty about this and will take off quite a few points if you get the significant figures wrong. So the first thing we want to do is be able to look at a number and say how many significant figures it has. And here the rule is kind of simple. It just says start at the left, move to the right until you reach your first non-zero number, then count to the right, counting each remaining digit. So here are some numbers. We want to determine how many significant figures they have. So here I start at the left, go to the right till I hit the first non-zero digit, and then I start counting digits. 1, 2, 3. So this first number has 3 sig figs. Here I start at the left till I get to the first non-zero number, so in this case 4, then I start counting digits. 1, 2, 3, 4, 5. This number has 5 significant figures. Here's another one. Start at the left, go to the right until I get to the first non-zero number. In this case it's 3. I count digits after that. 1, 2. This one has 2 sig figs. And it's the same thing. If you hold tight to this, people will throw all kinds of crazy numbers at you. You start at the left, you go to the right until you hit your first non-zero number, in this case 1, then I start counting digits. I don't care if there's, these zeros are here or at the end. I start at the left, I go to the right until I hit my first non-zero number, then I start counting digits. 1, 2, 3, 4, 5, 6. This number has 6 sig figs. In a second, we're going to talk about determining how many significant figures we're going to have in the answer of a particular calculation. And how you gain or lose significant figures is something that's important. So if I need to make the number of significant figures in a number smaller, what I do is rounding. And there's one particular rule, and this is completely arbitrary, just everybody's decided to do this. If I'm trying to get rid of a 5, and only a 5, I have to look at the preceding digit to see, do I round up or do I round down? If the preceding digit is even, I round up. Or excuse me, if the preceding digit is even, I round down. If the preceding digit is odd, I round up. So this is just by convention. Everybody's agreed to do this, but it's important that we all agree on how we're going to do this. If I'm rounding and I'm trying to get rid of something more than just the individual number 5, I got to look at all the other numbers to be removed, and I say, is it closer to the higher number or the lower number? So we'll look at an example of that here in just a second. One of the things you don't want to do is do rounding in multiple steps where you say it's like kind of eating off the end, and I'll show you an example here in just a second. You don't want to round and then round and then round. Rounding is done in one step. So let's look at this. And this is what we're trying to do is round down to 3 sig figs. And here I have a number. It has 4 sig figs. I want to get it down to 3. And so what I like to do is say, where do I need to get to in this number to get to my 3 sig figs? So what I'm trying to do is get rid of the 0.5. And this is where this rule applies. If I'm only trying to get rid of the 5, I look at the preceding digit. The preceding digit is even, so I round down. So if I want to put this number into 3 significant figures, that is 164. Here's the opposite one. I have 165.5. I want to get it to 3 sig figs. It means I want to eliminate this 5. I look at the preceding digit. It's odd. It means I round up. So this is the only time that that rule applies, is when I'm trying to get rid of a 5 and only a 5, I have to look at the preceding digit. That's it. After that, the question is, am I closer to one end or another? So we're still rounding to 3 sig figs. I give you this number right now, it has 6 sig figs. I want to round it to 3. So same thing I want to find. So if I want to get to 3 sig figs, I start at the left, go to the right, 1, 2, 3. This is where I want to shave my number off. I want to round it. And like I said, you don't want to do repeated steps. You don't want to say, oh, 1 rounds down to 2, and 2 rounds down to 3, and 3 rounds down to 5. You know, even though we end up with the same number, doing that can lead you to some what's called rounding error, and that's what you don't want to do. So here I've decided I need to clip off this 0.321. The question is, do I round down or do I round up? And really the question is 145.321 closer to 145 or 146? Do I want to round down to 145 or do I want to round up to 146? And between those two, that's the question. Is it closer to 145 or 146? So 0.321 is closer to 145, so I round down. So this number rounded to 3 sig figs is 145. So here, if you look at this, and this is where rounding error can kind of get you. I give you this number, and I say I want to round it to 3 sig figs. So what I'm trying to get rid of is 0.51. 0.51 is closer to 146 than it is to 145. So when I do this, I'm going to clip this piece off. It's going to round up to 146. Likewise, if I take 145.49, I'm trying to get rid of that 0.49. 0.49 is actually closer to 145 than it is to 146. So I'm going to clip this and round it to 145. So scientific notation is an important part of significant figures, and we'll see why in just a second. The formal definition of scientific notation is you take a number and you place it so that there is one non-zero digit to the left of the decimal place, and then you multiply by an exponential factor that will compensate for the moving of this digit. One of the most important things to remember is that if you take a number and put it into scientific notation, you cannot gain or lose significant figures when you do that. So if I put 4 significant figures in, I get 4 significant figures out. So let's do some basic ideas, and we'll see why scientific notation is kind of important with sig figs. The idea is some calculators have a function that will do this, or you can also kind of do it in your head. I give you 10.55 and I say I want to put it into scientific notation. So that means I want one non-zero digit to the left of the decimal place, so I need to move this decimal place to the left. If I move the decimal place to the left, I will be multiplying by 10 times some positive exponent, and the positive exponent will be 1 for every place that I move. So I've moved it 1 place to the left, so it'll be times 10 to the first. Notice I'm putting 4 sig figs in, I'm getting 4 sig figs out. Likewise, if I move the decimal place to the right, it will give a negative exponent. So if I give you this number and say I want to put it into scientific notation, I need to put 1 digit to the left of the decimal point, so I need to move this decimal point over 1, 2 digits. And in doing that, that means I've moved to the decimal place over 2 digits, so it's going to be multiplying by an exponential factor of 10 to the minus second. So 1 digit to the left of the decimal place. If the decimal place is moving to the left, you get a positive exponent. If it's moving to the right, you get a negative exponent. Here I had to move it 2 decimal places to the right, so it's going to be times 10 to the minus second. When we look at this last number, we can see we need to move the decimal place to the left. We move it 1, 2, 3 digits. Because we're moving to the left, that means the exponent is going to be a positive number. Because we moved it 3 digits, we need to raise it to the 3rd power. Notice we are putting in 5 sig figs. We're getting 5 sig figs out. Where scientific notation is really helpful is when we're dealing with a large number. And what we want to be able to do is give large numbers, make sure that they represent the proper number of significant figures. And this is where you kind of see this. if somebody writes a large number without a decimal point, it becomes ambiguous whether this number has 5 significant figures or 3 significant figures. So all the rules that we've been talking about in terms of significant figures all assume that we're dealing with a number that has a decimal point inside of there. When we don't have a decimal point, then it's really up in the air. So when we deal with large numbers and we want to be able to be very clear about how many significant figures it has, there's 2 main ways that people have done with this. And what they do is they put a decimal point at the end of the number. And that means that the zeros are significant. So if I write 12500 and put a decimal point at the end, it makes it very clear that those 2 zeros are significant. So this number is written has 5 sig figs. But that's kind of outdated. People don't really write it like this anymore. The preferred method is, if I have this number and I want to clearly show that it has five significant figures, what I do is I put it into scientific notation and make sure that the scientific notation has the right number of significant figures. So here, if I take this number, I put it into scientific notation, it's very clear now that this number has 5 significant figures. And if this number originally only had 3, I would have left the 2 zeros off. So you take large numbers, you convert it into scientific notation, and then you make sure to represent the proper number of sig figs in the number that's in scientific notation. So there's really only 2 main rules that we're going to be looking at in terms of how many significant figures does an answer have after a calculation. And with this, the first one is adding and subtracting numbers. The rule says that the input number with the fewest number of digits to the right of the decimal place determines the number of digits past the decimal place in my answer. So this is where it gets a little tricky. Notice we're not talking about the total number of significant figures. We're talking about digits past the decimal place. And that's kind of strange. It's a little bit different. I do a calculation and I say, I'm adding these 2 numbers together, and I say put the answer in the right number of significant figures. What I look at is how many digits are to the right of the decimal place. This one has 3 digits to the right of the decimal place. This one has 1 digit to the right of the decimal place. The one with the smallest number determines how many digits past the decimal place in my answer. This one has 3, this one has 1, so my answer can only have 1 digit past the decimal place. That's how the rules for significant figures work for when adding and subtracting. So in this case, I need to get rid of this 1 0. That in order to reduce significant figures, what I do is round. I want to get rid of these 2, so I round down to 111.1. Do the same one. I subtract these 2 numbers. In order to figure out how many digits past the decimal place in my answer, I look at the digits past the decimal place in my starting numbers. This one has 3, this one has 2. That means my answer can only have 2 digits past the decimal place. And so here it looks like I make a mistake, and this is kind of one of the problems that you want to make sure that you're aware of, is that your calculator has no idea about significant figures. And one of the main things you don't want to do is blindly write down a number that your calculator spits out on an exam, because the calculator has no idea how many significant figures it really should have. So what will happen is you'll get an answer out of your calculator that has like 10 significant figures. And if you copy that out on your exam and the answer is only supposed to have 3, you'll probably get points taken off. So that's one of the things. Your calculator does not know how many significant figures. Most of the time it will give you way too many significant figures. And in this case, if you put these 2 numbers into a calculator, it will give you an answer that has too few significant figures. This says that my answer should have 2 digits past the decimal place. So calculators don't put an extra 0 onto a number. It's up to you to do that. So when I do this calculation, I know that my answer needs to have 2 digits past the decimal place, so it's up to me to add it. So here I add another 0. Now I have 2 digits past the decimal place. So the calculator won't realize that. Probably the most important rule is when we're multiplying or dividing a number or some numbers in an equation, how many significant figures should my answer have? And the rule says The answer must have the same number of significant figures as the input number with the fewest number of significant figures. So we look at the input numbers, say how many significant figures they have. The one with the fewest number, that's how many significant figures my answer should have. So here I do this calculation. I say put the answer in the correct number of significant figures. So same thing, you put this in your calculator. This is what the number you're going to get out. It's up to you to place it in the right number of significant figures. I look at my input numbers and say, how many significant figures do they have? This one has 1, 2, 3, 4. This one has 1, 2, 3. The one with the fewest number of sig figs determines how many sig figs in my answer. So this one has 3. This means my answer can only have 3. So I look, 1, 2, 3. This means I want to round. I need to get rid of the 5, 2, 2 here. The question is it closer to 868? Or is it closer to 867? So 0.522 is closer to 868. So when we're done, we get an answer with 3 sig figs. I do it here. Now we're doing a division. I plug it in my calculator. Once again, it gives me way too many significant figures. I look at the input numbers and say, how many significant figures do they have? So the top one has 2, the bottom one has 3. That means my answer can only have 2 significant figures. So when I look at this, I want to figure out where 2 significant figures are at. So I start at the left, go to the right, start counting digits. So I start with 1, 2. So that means I need to round and remove the 0.1869. And with that, it's closer to 0.14 than it is to 0.15. So I'm going to round down. My answer is 0.14. So there was 2 sig figs, was the smallest number of a significant figure in my input number. So that means how many sig figs my answer should have. So taking a moment and notice there's a very big difference between adding and subtracting and multiplying and dividing. So with the adding and subtracting, it was the number of decimal places or digits past the decimal place that determined it. The total number of sig figs didn't matter. In multiplying and dividing, it's the total number of sig figs that go in. So one last idea is that during conversions of any type, you really shouldn't lose significant figures. And there's 2 main types of conversion units. There are these things called exact numbers. And when we have exact numbers, they tend to only write them with a certain number of significant figures, but they actually have an infinite number of significant figures. So the idea is, what do I mean by exact numbers? So I say I have 3 pennies. That means I have exactly 3 pennies. That means I have 3.0 with an infinite number of zeros behind it. That's what we mean by exactly. So the idea is this unit of 3 pennies should not affect my significant figures of my calculation because it has an infinite number of significant figures. So one you're liable to see is this idea that 100 centimeters is exactly 1 meter. Exactly. So even though we tend to write it as 100 and we tend to write it as 1, both of these numbers have a decimal place and an infinite number of zeros behind it. What we're really trying to say is this conversion unit will not have an effect on the number of significant figures. It's the input number that determines the number of significant figures, not the conversion unit. So even though we write it very simply, that's what we mean by exactly. So here's a prime example. I use this conversion. I give you an input number. My input number has 5 significant figures. As written, you would say, oh, this one has 1 sig fig, this one has 3 sig figs, so my answer should have 1 or 3 sig figs. No, it's a conversion unit. It's an exact number. It has an infinite number of significant figures, so it has no effect. So of these 2, the one with the fewer number of sig figs is this original input number. It has 5, so my answer needs to have 5. So you're going to get into some things like molecular weights and some other conversion units that are not exact, but the idea is you should be able to go and look up that conversion unit to a proper number of significant figures that will not have an effect on your answer. So in general, conversions should not affect the number of significant figures in your answer. And one last warning, and this has to do with what's called rounding error. So there's the different rules in terms of how many units are inside of my answer. Say I had a calculation that involves 3 different steps. So I multiply by a number, and then I add a number, and then I divide by a number. What I don't want to do is round after each step. So I don't say, oh, I multiply by 3 and then I round it to 2 sig figs, and then I subtract 1 and then I round it to 1 sig fig. You don't want to do that because it creates this cascading rounding error. So you're changing your answer. And then if other people do the calculation and they don't round the same way, they're going to get a different answer out of it. So what you do is you do the calculation. You don't worry about significant figures. So you do the 3 different steps. You get an answer that comes out. Then what you do is you look at the input numbers and whether you're multiplying or dividing or adding, subtracting, and then you say how many significant figures should my answer have. Then what you do is do one rounding at the very, very end. So just like other things, you only round once during a calculation.